Good morning, everyone. Today I'm going to talk to you about a very common challenge you will have to deal with if you want to perform high accuracy measurement or whatever it is that you want to measure. In our specific case, I'm going to talk to you about measuring gravity or accelerations, which are basically the same thing. So this challenge is related to disturbances. Disturbances are environmental variables affecting the output of your sensor and worsening its accuracy. The method we propose is called the gain method. Before I start, let's introduce myself. I am Lorenzo Iofolla from the National Institute of Geophysics and Volcanology in Italy, and I'm talking on behalf of my two co-authors, which are Massimo Chiappini from my same institution and Francesco Santoli from the Italian National Institute for Astrophysics. The title of my presentation is GAIN, a machine learning approach for airborne, maritime, and submarine gravimeter systems. This presentation was originally held at the European Geoscience Union General Assembly in Wien, April 2024. Okay, so let's get started. As I anticipated, we want to measure accelerations, and we want to measure them from a moving platform. What do I mean for moving platform? Well, a moving platform might be a boat, for example, or an airplane, or a submersible, or even a space satellite. There is a common issue with these platforms, which is that there are plenty of disturbances, so that our gravimeter, for example, is exposed to such a situation, in which, as you can see, it is actually measuring the gravity field, which is the desired signal for us, but it is also its output is also affected by other signals, which are inertial accelerations, vibrations, temperature variations, unaccounted rotations of the reference frame, so the moving platform, and so on and so forth. So that the output of the gravimeter is very difficult to interpret, and sometimes the information we are looking for, which is the gravity signal, is lost. So our solution is based on three pillars, which are a multi-sensor system, the second pillar is a machine learning, and the third pillar is the training platform. Let's see in details. So a multi-sensor system is a system represented in this drawing. So we have the three gray elements are the three axes of a high sensitivity accelerometer. The brown boxes are the three elements of the three-axis gyroscope to measure the rotations of the reference frame. On top, there is a GNSS antenna to track the movements of the moving platform. Then we might have this blue element, an altimeter, barometer altimeter. And then a small one you should be able to see are these little brown elements, which are high sensitivity thermometers to measure the thermal gradients within the instrument. So that the diagram we have seen before becomes like this. So the gravimeter is still affected by the signal and the disturbances, but now the disturbances are also measured by the so-called supplementary sensors. And so the output of our system is made of multiple signals, as you can see on the right. And in this case, the information we are looking for, the gravity signal, is there, hidden, and we need to find a way to retrieve it. So our solution is the second pillar, it's machine learning. I guess you're already aware of what machine learning is. Anyway, it is a type of artificial intelligence in which algorithms are able to learn from data, the so-called training data. Basically, these algorithms recognize patterns and learn how to make predictions. In our case, they need to learn how to retrieve the gravity signal from all the complexity of signals we have seen before, the output of the multi-sensor system. But now there is a new challenge, which is the need for training data. Where do we get our training data? The answer is the third pillar. In the GAIN method, the third pillar is the training platform. The training platform is a setup that we use only in the laboratory, and we install temporarily our multi-sensor system on top of the training platform. And the role of the training platform is to replicate the environment that the multi-sensor system will face during the operations. So basically, it will have to replicate all the disturbances that we will find on the training platform, on the moving platform, sorry. So for example, this three vertical cylinder represents linear actuators that are able to tilt the plane on which the accelerometer is installed, and also to simulate, to induce a vertical movement. Then we have horizontal actuators. We have this red lamp that is there to induce variations of thermal gradient within the instrument. So basically, the GAIN method can be divided in three operational phases. During the first phase, we take our multi-sensor system and we install it on the training platform to collect training data. Once we have collected training data, we can move to the second phase, in which we train our machine learning algorithm. Once the machine learning algorithm is trained, we can take our multi-sensor system and install it on the moving platform, such as an airplane, as you can see on the right, so that we can collect the operational data that can be processed and interpreted using the machine learning algorithm that was trained in the phase before. So we finally, here are a couple of experimental setups that we have implemented so far. Here on the left, you can see a high sensitivity accelerometer, triaxial accelerometer, including 11 high accuracy thermometers spread all around the instrument, which is warmed up by this lamp that we were moving around to induce a thermal gradient from different directions. And there is already a publication about this work, and I will add a link in the comments. On the right, instead, you can see a platform similar to the one I've shown in the slide before, and which you can see the movements of the plane that should remind you the pitch and roll tilts of the deck of a boat. In this case, the multi-sensor system was also featuring a gyroscope to measure exactly these rotations of the platform. So we finally got to the end of my presentation, and let me show you our contributions. So first of all, we identified a very common challenge, which is related to disturbances in high accuracy measurements. Then we have proposed a solution, our solution, which is called GAIN method, which is pivoting the machine learning. There are already some results that have been published, and as I said, just take a look in the publication in the comment. In the future, we will develop the same type of experiments, but to deal with different type of disturbances. So not only temperature, but also, for example, pitch and roll rotations of the moving platform. So this was the end of my presentation. If you have any question, you can text me or contact me through email. I will be really happy to help you understanding our method. Thank you very much, and goodbye.